everyone, welcome back to SAT Math Question of the Day with Professor Emeritus Seth Chaiken, University of Albany, and Joel, Seth's brother. We're here to hopefully hopefully show you how to approach SAT math questions, maybe even other math questions. These practice questions come from the official Khan Academy SAT practice, which we strongly encourage you to do. They have about 800 questions broken up into 40 categories, and these are the categories that are on the SAT. So this is the category complex numbers. They give you 20 questions per category. These we're going to do, we are going to do questions 5, 6, how come I can't annotate? Oh, I know why I can't annotate. There we go. We're going to be doing questions 11 through 15. They give you 20 of them because we're at the third level. And we're just going to do one slowly, and then we're just going to very quickly do the rest of these. Okay, so let's start. This is obviously on complex numbers. On the SAT, you're not going to be told the topic on the question. Which of the following is equivalent to this complex number shown above? I is equal to the square root of -1. That's a definition, right? I is defined as the square root of -1. So
Okay.
So you basically.
Well, I would say though that the significance of that definition is, and the total idea of complex numbers goes like this: you do arithmetic with them. Using the same old laws of arithmetic that you've been familiar with since first grade, with one additional rule. Whenever whenever I appears as a square, or I times I, you simplify it to -1.
Right. Yeah.
And so I'd say this is a better definition of I.
Yeah.
Than that.
Absolutely.
Okay. Absolutely. Now, so that I could give you. I'll give you the first 3 ways of solving this problem. Way number 1.
Okay.
Okay. We start with the given expression, and we multiply out -8 times 7 times I minus 8 times 3i squared. Okay? Now, 8 times 7 is 56 with a minus. So this simplifies to -56i. And then, let's keep this the same. 3 times I squared simplifies to 3 times -1.
Right.
Okay. And this is pretty complicated on the right, but an easy way to handle it is that you see that there are 3 minuses multiplied together.
Yep.
So the answer is minus the product of the positive numbers, 8 times 3, which is 24. And so we get the answer -56i minus 24. And then we look at the, it's not this one. We look at it and see it matches B. So
Yep.
B is an answer.
Yep. Yeah.
Okay, that's way 1.
Okay.
Way 2. Well, we apply the rule that I squared is simplified to -1 at the beginning. So we simplify the given expression to minus 8 times 7i minus 3 times minus 1. And we go from there.
Yep.
I don't know. Here there are two alternatives. We could multiply the minus 8 by the other two terms first, or we could simplify the minus 3 times minus 1 first. Let's do the minus 3 times minus 1i first. So we get minus 8 times 7i. Two minuses. 3 times 1 is 3. Right. So it's 3. And then multiply the minus 8 by the 7 and get minus 56 minus 24. And remember to put in the I. Again, it matches.
Right.
That's way 1. Way 1. Way 2. And now here's A3.
Okay.
We look at the 4 choices and observe that the imaginary term for the 4 choices, the imaginary terms are all different.
Yep.
And therefore, using the fact that, unlike life, the choices on the SAT are carefully built by the test makers so that there is one and only one correct choice.
Right.
We could merely calculate what the imaginary part of this is and match it to the one choice that has that imaginary number as its answer. So the idea is we could simplify this to be minus 56i plus, I squared is real, plus some real number we don't care.
Right. We don't care about.
To know. And then match this 56 with this 56. It doesn't match 80i. It doesn't match 24i. And it doesn't match minus 32i.
Right. Yeah. Yeah.
So
yeah.
This is
yeah.
way 3.
So way 3 is by far preferable because way 3 you could do very, very quickly. And way 3 takes advantage of using, it's not a brute force method, but it uses more intelligence than brute force. And also, but to do way 3, you have to invest maybe 5 to 10 seconds deciding whether way 3 is the best way. And I would say it's a good investment in time to, when you approach SAT questions, to see whether there's a really fast way to do it. And it could save you a lot of time. And way 3 looks like it's preferable. Yeah.
Right. And there's a way 4. You could apply way 3 to the real part of the value as well, because No, you cannot, because you cannot do that, because the real part of A is 0, and the real part of D is also 0.
Yeah, right.
However, you could apply a variation of way 3 if you notice that there are three real parts were given: 0, minus 24, and minus 56. And then when you look at the expression, you see this term is going to contribute an imaginary part, and this term will contribute a real part. And so there's only one term that gives a real part.
Right.
And it will be non-zero.
Yeah, right.
And so you could rule out A and D right away, and then do the arithmetic. Minus 8 times minus 3 is 24 times I squared is minus 24, and pick this one.
Right. Uh, right. Yes. 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 So one thing about that we should mention explicitly that every number in the world can be written as a number that a plus bi, where
Complex number in the world.
every number in the world can be written in general as a number where you have a real part and then you have a complex part. It turns out that for numbers less than 10th grade, b has always been equal to 0. But it's always been there. But it's always been there theoretically, but b has always been 0 until you learn about complex numbers. With complex numbers, b becomes non-zero. And that's why when Seth's talking about the real and complex parts of a number, he's talking about the real part, which would be the a part of a number, and the b, and then the complex part would be the b part of the number.
Yeah. Well, the more conventional term for the part that is a real number times I is the imaginary part.
Right. Okay.
So in a complex number, the whole number is considered complex, whether or not whether it's, and then among some numbers, some complex numbers are real, and they are ones with the imaginary part being 0. But in any case, the real part of a complex number is when you simplify it to real A plus real B times I. The A is called the real part, and the B times I is called the imaginary part.
Got it. Okay. Got it. So I was a little bit wrong. Okay, so now what we're going to do, because
now wait, okay. What? Yeah, hey, let's go on. What happens if you divide complex numbers? A plus bi plus c plus di.
Well, you're supposed to rationalize.
How this is not? How could this is not in the form a real number plus an imaginary number. You have this is a fraction.
Right. Yeah. So you have to what's known as rationalize the denominator. If it's a
plus so the fact is what we said, what Joel said, every complex number can be written in real plus imaginary form. Well, that is true because when a complex number is given in the form that doesn't look like real plus imaginary, you could take that weird form and multiply it by an expression of 1 that is the so-called complex conjugate of the denominator.
Yeah,
divided by the complex conjugate of the denominator. And when you multiply it out, you'll find that the denominator is real.
Right. I know. We did that. You
didn't say it.
I know, but
right. C squared plus D squared is real.
This is what Seth's talking about. Talking
about. And I wouldn't call this junk. What's up here is some real value,
right,
plus some imaginary value,
right. Which you
and then so this real value A is when you divide it by the real value of the denominator, you get a real value.
Right.
This complex value, when you divide it by the real value of the denominator, you get another real value. So this has the form, with different A's and B's, A prime plus B prime I.
Right.
Exactly. Where A, B prime A prime are all mathematicians write it this way.
That's real. The fancy way of writing it. An element in the real set. That's too cool for me. And then you have this little double R. It's too cool for me. Yeah. Great.
Yeah.
Okay, so this is a big review of complex numbers. It's be very very good. So what we'll do is we'll do the next. We're gonna blast through the next 4 questions. What we'll do is we'll take turns. I'll do one. Seth will do one. I'll do one. Seth will do
All right.
one. And then I think we should approach it the same way Seth did. We should invest a little bit of time. That's the way I'm going to do it. I'm going to invest a few seconds to see whether I could look at the answers and pick the answer off immediately without having to actually do the detailed calculations. But we'll do it both ways, okay? Because we need to check. So let's.
Well, I want to give some advice to people listening to this.
Yeah.
The advice is learn the standard way to do the complete simplification of complex number expressions. Learn and practice that first.
Yes.
And then put into your repertoire of tricks the technique to see what the different real parts of the answers, or see what the different imaginary parts of the answers and match them. Right. That technique. Do that after you really, really understand how to complete simplifying of complex number expressions.
Right, so this brings us a conflict as to what the purpose of our video is. Is the purpose of our video to show everyone how to do SAT questions the most efficient way? Or is our purpose?
No, I'm saying the most efficient way to do SAT questions is first to thoroughly understand the math behind them.
Right.
And second, to take advantage of regularities, coincidences.
Right.
Easier than random question design on the SAT.
Right. Exactly. That's exactly right. So in other words,
the approaching SAT questions is not a matter of learning an approach just before you take the test. The approach is approaching your study process, and then incorporate the results of your study process into learning strategies for approach when you actually take the test.
Right. So in other words, when I opened the video, I wasn't really right. I should really open the videos and saying, how to approach preparing for the SAT.
Yes.
And preparing and taking the SAT. It turns out that there's slightly different approaches. When you're approaching studying for the SAT, you should learn how to do everything the long way. When you learn to approach SAT questions on the day of the SAT, you should keep yourself open for the coincidences and the tricks.
Yeah.
Wow, okay, look at that subtlety. That's why we need Seth.
We're subtle.
That's why we need Seth.
Okay. So let's see if other questions require more of the calculation of this simplifying of complex numbers.
Well, it's possible that questions 16 through 20 do, but we're not going to do 16 through 20. We're going to do 16 through 21. Okay,
well, let's see how they progress.
Okay, let's see how they do. First we haven't seen congratulations, we got it right. We can solve.
No, our answer coincides with their answer.
Fine.
And we think we are right.
Okay, fine. Okay, we can solve this using the distributive property. I have no idea what the light bulb means. You basically do the distributive property, and then since I squared. By the way, look, they did since I squared is -1. They did what Seth did, and boom, there you get the answer.
Yeah. Okay. Well, so they only gave one method.
They only gave,
and
one
they
method.
did not mention the strategy of only partially completing the arithmetic.
That's right, but that's not how you should approach studying for the SAT. This is Khan Academy where you're presumably studying for
Yeah.
the SAT, not taking the SAT questions. Well, we're covering everything. Okay, so now I'll do the next one,
Oh,
and then we'll take turns. Now, negative numbers are involved. Negative numbers. If you're going to make a mistake in algebra, you're probably going to make a mistake with a negative number. So there are negative numbers galore at these problems. So I don't know about you, but I'm going to try to be really careful, and I'm probably going to double check my work. Okay, next question. Let's see. Oh my, whoa, 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 whoa. Oh, how come I got a hard one? Let me first get my annotation working. Wow.
yeah.
Wait.
Mm.
3 minus I cubed.
Yeah.
Wait, hold on a second. 3 minus I. Now I have to invest a second. Is there a way to do this quickly? There is a way to do this quickly, but I forgot what it is. Oh, am I really going to have to do that? Am I really going to have to multiply all those things out? Oh, but I'm using up my 10 seconds of cleverness.
Yeah.
Oh, there is a way to do this, but I forgot, so I have to just do it. I have to do 9 minus 6i minus I times minus I is plus I squared, which is a minus 1. So this is an 8 minus 6i. Now, I'm going to try... Now...
Ouch.
Wow. Now I'm with a little bit of experience that I have. Now I'm going to try to do it.
You're going down the rabbit hole.
What, did I do this wrong?
No, I don't know if you made a mistake. I can't tell.
Okay. What I'm going to try to do now is I'm going to try to see. Let me do the real. First of all, the real parts are all. Lucky me. The real parts are all different. So all I have to do is just the real part. Oh, I can do that. That's 24 minus 6 plus 6, because it's a minus 6 times a minus I. So it's a plus 6i squared. So it's 24 minus 6, which is 18. So I think it's B. I have like an 80-90% confidence in this. If I wanted to really, like on a test at school, of course you can't do this. You would have to foil the whole thing out. If I had extra time, which I wouldn't on the SAT, I would check the complex part. The complex part's easier. The complex part, wow. All the complex parts are the same. Oh, so then that's it. I'm going to take a chance. So, okay. I mean, in terms of practice, isn't that really the only... It doesn't make any sense to foil the whole thing out to get the complex parts, because look at the answers. All the complex parts are the same, so what difference does it make if you get the complex part, right? It makes no difference in this question.
Yeah.
So we're using a little bit of test-taking logic. So let me then... I guess I'm done, because I would run out of time by now.
All right. Well, I'd like to show a different strategy.
Okay, that's fine.
So if you want to compare to their answer, or should we look at my strategy?
I'm dying to know whether I got it right.
All right, you don't want to die, so let's look at your.
It's possible I got it wrong again because I did it a little fast.
It's likely. Let's see.
Well, let me tell. So I don't like what Seth said. First of all, we don't really care about the complex part at all, do we? Knowing the
imaginary part.
Okay, the imaginary part. Fine. This number here. No, this number does come into it.
Frankly, I didn't follow the calculations when you spoke them out.
Yeah, that's 3 times 3 is 9.
I'm not going to follow them.
Fine. You could do what you want. I'm just double checking my work. This is a negative 6i, negative 3i plus negative 3i is negative 6i. And this is a negative times a negative. It's a positive I squared. So it's a negative 1. So it really is 8 minus 6i times 3. So this is a 24. And this is a negative 6i times negative I is 6i squared. It's a negative 6. I think I'm right. I'm wrong? Am I wrong, Seth?
Well, compare. check
Okay,
the
fine.
answer and see
Oh, I
what
really
happens.
hope not.
Let's see.
Yes, I'm right. I'm
Good,
right.
good.
I'm right. Okay, Seth, now go ahead. Do it a cleverer way. But
All
don't
right.
forget, you have to make sure people at the level that they're at can't
Well,
do.
you judge that. You
Okay, I'll
judge that.
judge that. I'll judge that.
Okay. Here's my idea.
So maybe you use another color.
I will use the binomial theorem and my memory of what the binomial theorem says when the exponent is 3. So I will write down a plus b to the third power
Okay.
equal to a to the third plus 3a squared b. Could you get rid of that plus I squared there?
Yes. I can if you just bear
Please.
with me. Yes. Just be patient. Be patient. Okay. Go ahead.
Good. Okay, thank you.
You're welcome.
Plus 3ab squared plus plus b cubed.
Right. Okay.
And then we substitute a for 3
Yep.
and b for minus I.
Yep.
Okay, now we apply Joel's strategy that only the real part is interesting.
Right.
And so A is real. So we're interested in the real part.
Yep.
A is real. So to calculate the real part, we need to include A cubed.
Yep.
Right? And what's A? A is 3. So A cubed is 27.
Right.
Now, A squared B is A squared is real and B is imaginary.
So forget it. Just leave it.
So don't care.
That's right.
Following the same pattern, 3ab squared is real. So let's calculate that. 3 is 3. A is 3. B is minus I. So we need to calculate minus I squared.
Which we know is
Now,
negative.
so I'll remind people how to deal with this. Minus I is minus 1 times I, and the whole thing is squared. And so this simplifies to minus 1 squared times I squared. Minus 1 squared is 1, and minus I squared, by the weird rule about squaring I, is minus 1. And so this is equal to minus 1.
Fine. So you have 27 minus
Okay.
9.
So we have 3 times minus 1, which is, so we get 3 times 3 is 9, times minus 1 is minus 9. So the real part is 27 minus 9, which is what, 18?
No, you forgot the b cubed. Oh, b cubed is complex, right?
Yes.
Yeah, b cubed is complex. Yeah.
No, it's b squared. Yeah,
No,
b
no, no.
Oh, yes, absolutely. Yeah. Oh, yeah. Good point. Plus another don't care. Another don't care value.
Right. Yeah, another don't care value.
Yeah.
Okay. That requires you to know the binomial theorem, which many people won't know right off the top of their head. And also, it does require some fancy schmancy calculating here. But you have to do this. I mean,
well, you need to substitute. Worry about the signs. Yeah.
I mean, there's no way out of worrying about negative signs when you deal with complex numbers like these. There's just no way out of it. Okay, not a bad way, but I personally think my way is probably.
But I think my way is more robust against mistakes when you
Yes, probably.
when you when if
Probably.
when you as we say foil something out.
Yeah, probably. Because you have to do this really nasty thing here.
Yeah.
This -6, this is where you're gonna make the mistake. This -6i times a negative I.
Mm.
That's a nasty one. And if you go back to the video, you'll see how much time I spent on that and how I
Mm.
redid it.
Yeah.
Okay, next question. So Seth,
Okay, let me say one more thing.
go
It's
ahead.
handy to know, in other words, memorize uh, an additional rule for simplifying complex numbers. The basic rule is that I squared is simplified to -1.
Right.
A derived rule that is very helpful to actually memorize is that the square of -I is also -1.
Right. Yeah. 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 Be careful about that. If the negative sign is inside the parentheses, it gets cooked. It's the same
Yeah.
reason why -4 squared is equal to 16. It's the same
Yeah.
reason, right?
The
The
same
negative
thing. Yeah,
sign is
right,
getting
right, right.
squared.
So, 2 squared
Yeah.
equals 4, and that's the same thing
Yeah. Yeah.
as -2
Right. Yeah.
squared.
As
For the
opposed to
same for
something
the
like
same
this.
reason.
Right. As opposed to what -4 squared is -16. Okay, because the
Yeah.
negative sign is not being squared. Okay, we
Yeah.
should probably move on. I think.
Okay.
Okay. So now okay, next question. Wait, we have to clear this. Clear all annotations. Okay, Seth. So now this is your big chance to now try to do this as fast as possible. Okay, we're already done with all the concepts. So try now. Let's both try not to explain a lot of stuff because we've already did all the explaining. Because this video is going to go on forever. No one's going to watch it anyway. Okay, so just blast right through the question. Okay, go for it.
Oh.
As if you were doing it on the SAT because you already explained all the theory behind this.
Okay, I think I have to do more calculating out because there's a lot of sharing of imaginary and of real parts among the answers. So let's see. Okay, I'm going to do the simplification within the parentheses. So I'm going to simplify I cubed to become -I. I thought of that in my head, but what happens is I times I equals -1 times I, which is what I said, -I. So it's -I. And then, so my I cubed is -I. The negative of IQ is, the negative of -I is +I. So this simplifies to 1 plus I. And then I'm simply going to multiply it out.
Wow.
Okay. The real part is -3 times 1. And the plus 2i times I is -2. So that's the real part. And the imaginary part is 2 times 1 times I, 2 times 1 plus -3. And this is the imaginary part, and simplify the arithmetic. This is 2 minus 3, which is -1. So I get -I. And this is -3 plus -2, which is known as -5. And then I look at the answers. -5 plus -I is that.
Okay, so there really was no super fast way to do this.
Nope.
No, there really wasn't. Okay, so let's see.
Yeah.
Congratulations. Okay, I'm gonna let me do the next one. Um, great. Okay, so there really wasn't any. That's because the answers had too many similar choices.
Yeah. Yeah. But the strategy I followed was to, simplify the lower powers of I first. So I simplified the I's within the parentheses first.
Right. Right. Makes sense. Yeah. Okay. This one. Oh, okay. Well, let's see. Let me quickly look at the answers. You have, ooh, every real part is different. Oh, look at this. Whoa,
Oh,
look at
great.
this.
Oh, wow.
Every real part is different. So maybe that's a good approach. So let me just do the real parts. The real parts here would be 4. Now I'm going to write the real part like this. -6 -6I squared. Oh, that's easy. 4 plus 6. 10. Done. Answer. Done. So let's see.
Good.
Okay. Great. This is how you approach SAT math questions when you when you basically know what you're doing. But Seth's right. When you study for the SAT, don't study by doing them out enough so that you have enough confidence that you could do a problem like that fast. Okay, Seth, your chance to do question 5. Yes, the real part. So in this question, the reason why it worked is because all the real parts were different. I invested a few seconds just to look at the answer. Not a bad way to approach the problem.
I think it's more like 2 seconds. One, at least maybe like 2 seconds, 1 or 2 seconds.
Yeah. Well, that's one of the things you could do when you're practicing is practice getting better at approaching problems like this. Yeah. Okay. Okay. Next and last question. Okay. Oh. Okay. Let me go like that so you have all the choices.
Oh,
Okay. There you go, Seth. Go for it.
oh, oh, well, I have to do this. Okay, I will. Oh, great. So this is one where you only have to find the imaginary part
Yeah.
because that's what they're asking for.
No thinking involved. Yeah.
Okay, so imaginary part. The imaginary part is obtained by multiplying the imaginary part of the left by the real part of the right, multiplying the real part of the left by the imaginary part on the right. Okay? And that gives you the imaginary part. So I'm going to get the imaginary part. Here we go. 2/3 of -1/3 is -2/9. And 1/2 of 12 is 6. And so the denominator, it has a denominator of 9. And it is, okay, is it valid to say, no, it might simplify. It might simplify. So I have to work it all out. So I have to simplify this. 6 is equal to, oh gosh. Okay, I just have to do it. I have to well, here we are. I want to simplify this. So I factor out a 2 minus a 9th plus 3, which is 2 times 3 minus a 9th. And 3 is, what's 3? 3 is 27/9. Right? 9 times 3 is 27. Minus 1/9 is equal to 2 times 26 over 9. And there's no common factor. This is in simplest rational form. And the only answer that has a 9 in the denominator and is in simplest rational form is D. So I picked D.
Okay.
Notice and if you want to, so an optional step, which I would skip if this was on the SAT, because I want to save time, is calculate 2 times 56, and we better get 52. And don't use a calculator for this. In fact, don't even do it. 2 times 56, 6 to 6 and 6 is 12. Carry the 1. 2 and 2 is 2 times 2 is 4. Checks out.
Right. Okay. Okay. I mean, you stalled a little bit on the. You could have done 54 negative 2 plus 54 to get 52. Yeah. I mean, yeah. There's really no other practical way to do this. Oh, the other thing you could do is you could have thrown these out immediately, because look, 6 minus a little bit. This is only 2/9. 6 minus a little bit is not a sixth or a negative 6. These are very small numbers.
Oh yeah.
Right.
Good.
So that you could have, but that wouldn't have helped you because these two numbers are too close together. These two numbers look very similar. So throwing these out doesn't really help you.
Yeah.
Right. Okay, good. So then you're probably right. Let's see. It's always nice to get confirmation. So you say it's D, and you're correct. Wow, so we're 5 out of 5 today.
Actually, some people might use a calculator for this.
Yeah, because the digital SAT, that's right. Yeah, some people may use a calculator. The digital
However, the calculator will give you the answer as a decimal, which might be hard to compare with the fraction.
Some calculators, if you can be in fraction format now, and you can switch modes and stuff. Yeah. Okay, so I guess this completes us for the week. We did 5 of the middle questions on Khan. When we do the 5 hardest, we're just going to do 1 a day, and that'll spread those questions out. God knows when we're going to get to those, because we're in between now and when we finish, we're probably going to do about 400 or 500 questions. Now, maybe 200 or 300 questions from Khan. Okay. Right. Okay. Red part doesn't matter. Right. The real part doesn't matter because they're explicitly asking for the complex part. Yeah. Okay, everyone. Hopefully you got something out of all this. Okay. Just be careful with your negative signs. Okay, everyone. Please like us, dislike us, give us comments on our YouTube videos, or send us emails at satmathquestionoftheday@gmail.com. And if you have any SAT math questions you want us to go over, please email those SAT math questions to us at satmathquestionoftheday@gmail.com. Seth, are those raisins?
Excuse me?
Are those raisins from yesterday?
No, they are blueberries.
Wow, blueberries, Mike. Wow, blueberries are good. Yeah, soon in the Northeast, we're going to get fresh blueberries.
Yeah.
Yeah, those are still from... Okay, everyone, have a great day. Have some blueberries. Okay.
Happy weekend.
Take care. Have a good weekend. Bye-bye.
Stop. Yeah.